This is the fourth block of topic 22. In this lesson, you're going to learn how to find the area of a sector and the area of a segment of a circle. So two different types of areas and two new terms for us, sector of a circle and segment of a circle. So remember the pizza problem we've been looking at for a while, that we know that pizzas are sold by the slice. And so the owner is wondering how much pizza is in the slice that he sells. So that's a different question than how much crust does each slice has. Now we want to know how much pizza is in a slice. So when an 18-inch giant pizza is cut into 8 slices, we're wanting to know, in other words, what is the area of one slice? Well, we know how to find the area of a circle. The formula is pi r squared. So remember, 18-inch pizza means the diameter is 18, so that means the radius would be 9. So we could find the area of a full circle, or for a full pizza, by using that formula pi r squared and replacing r with 9. So the full pizza has an area of 81 pi inches squared. But since we have cut our pizza into 8 slices, we only want an eighth of that. So we want 1/8 of that 81 pi to find out what the area of one slice is. And so we can approximate that area, or we can simply write that as 81/8 pi inches squared. That's the exact area of one slice. But we could, of course, approximate that if it told us to round to something. But since pi is irrational, remember, if you're not giving rounding rules, you don't put the pi in your calculator. And 81/8 does not simplify. All right, it says, how is this problem similar or different than wanting to know how much crust is in one slice of a pizza? So remember, when we were looking at the crust goes along the outside of the circle. And so that is a portion of the circumference. When we're looking at how much pizza is in one slice, we're looking at area. So now we're looking at a portion of the total circle's area. So that's the difference. Crust is a portion of the circumference, and how much pizza is in the slice is a portion of the area of the circle. So it says, using his special pizza plate, and an employee who cuts a pizza can easily measure the central angle on that pizza plate. And because we know a whole pizza has 360 degrees, you can compute the proportion of the slice to the whole pizza by just writing that as a fraction. What is the angle of your pizza over 360 degrees, which is the total? And for example, if a customer chooses a slice that has a central angle of 13 degrees, you would put 13 over 360. And that's the fractional part that slice has of the whole pizza. Now, since we know the cost of a giant pizza is $23.99, we can figure out how much to charge for that slice by taking that fraction and multiplying it by the whole price of the pizza. So that piece would need to be 87 cents. So we can answer question 2 in our notes doing that same process. So we already found that the cost of a 13 degree is 87 cents. So you can put that in your notes there. If we want to know the cost of a 30 degree angle, then remember the portion of the circle is 30 over 360. That's our fractional part. It doesn't matter if you simplify that or not. You're going to multiply that by the cost of the whole pizza, which is $23.99. So it's not necessary to simplify that, but you can. You're going to get the same thing. So we can do 30 divided by 360 and multiply that, not subtract, but multiply by $23.99. And if we're talking about dollars, then remember we're rounding to the nearest hundredth. So that 9 makes us round up. That's going to be $2 for that slice of pizza. Now, just so you can see, we know that 30 over 360 would reduce to 1/12. So if I did 1/12 times $23.99, I'm going to get the same exact thing. So it really doesn't matter if you reduce that fraction or not in your computation. So we're going to do that same thing for the remaining 3 central angles. We're simply going to write the fractional part over 360 and multiply by 2399. Fractional part over 360 times 2399. Our central angle is a fractional part of 360 times 2399. Now, when you're putting this in your calculator, I'm always looking for ways to speed up that process. So if I go up and highlight where I did 30 divided by 360 and press enter, it brings that down in my calculator. So now I can just go over to the 30 and change it to 86, and I don't have to retype that entire thing. So rounded to the nearest hundredth, that would cost $5.73. Now on the next one, when I go up and highlight that and bring it down, this number has 3 digits. So when I do 210, notice it's replacing those, and I don't want to replace that division bar. So insert is in blue above delete. I'm going to press second delete and insert a 0 there. So that's 210 divided by 360 times 2399. And rounded to the nearest hundredth, that's going to be $13.99. And of course, all these numbers are going to have to be less than $23.99 because they're less than the whole pizza. So our last one, I can highlight that, scroll over, and change the 210 to 330, and see that that's going to cost $21.99. $21.99. So we can check our answers with the key here and see that, yay, we got all of those correct. All right, look at question 4 in your notes. This is giving us the definition of a sector, which is number 3 in your notes. There's nothing to fill out there. It's just filled out for you. But by definition, each piece of a pizza is what is called a sector of the circle. So by definition, a sector is the portion of a circle, so it's a part of the circle, bounded by 2 radii and an arc ending at each of those radius. So bounded just means that's the boundary. So you have 2 radii as your boundary, and then the arc that connects those 2 radii is the boundary. So this is our piece of pizza, and that is called a sector of the circle. So how do you find the area of a sector if the central angle is 13 degrees? What's the area of that pizza? Remember, it's just a portion of the whole area of the circle. So if we want to find the area of a sector of a 9-inch radius pizza and its central angle is 13 degrees, this tells me what portion of the total area I want, because I know the whole circle has 360 degrees. So I'm simply going to put 13 over 360. That gives me my fractional part that I want of, which means to multiply, the full circle's area, which is pi r squared. And we're told the radius is 9. Now, if you're not given rounding rules, when I go to put this in my calculator, I'm going to put the whole thing in except for the pi, because that's irrational. So 13 divided by 360 times the 9 squared. So the exact area of this sector is 2.925 pi square inches. Now, if I wanted it rounded, then I would just simply multiply this by pi. And I don't have to retype that in. If I press times, do you see how it brings the answer down? And I can multiply by pi. And then I can round it to whatever place value it tells me to. So in the problem that we're looking at, it looks like they round to the nearest tenth. So we can see that that 1 in the tenth spot, because of the 8 next door, becomes a 2. So this is approximately 9.2. Don't forget your units are squared since we're talking about area. So it's approximately 9.2 square inches. But again, it's just a fractional part of the whole area. That's what the area of the sector is. So we can generalize the formula for finding the area of a sector, which is question 5 on your notes. And we're using the Greek symbol theta for the number of degrees for that central angle. So the formula is simply to find the area of a sector it is equal to the central angle degrees, which we're using the Greek symbol theta for, over the full circle, which is 360 degrees. And we're going to multiply that by the area of the whole circle, which is pi r squared. So this is the formula for finding the area of a sector. What fractional part of the circle's area are you trying to find? Now, a segment of a circle is not just like a regular segment. So we're not just talking about the length of a part of a line between two given points. So in a circle, a segment, and this I believe is number 6 on your notes, already there for you. And it is, yeah. So your definition of a segment of a circle is the portion of a circle that's bounded by a chord and the arc that that chord creates. So in this case, this pink section here is a segment of a circle, that whole region that's shaded pink. It has chord AB and arc AB as its boundaries. So look at this picture and it'll help you see the difference between a sector and a segment. A sector always goes to the center of a circle because 2 of its boundaries are radii, whereas a segment does not go to the center of the circle. It's bounded by a chord and its arc. So hopefully you can see the difference between the two. They're both portional parts of the whole area circle, but they're found differently. So to find the area of the segment of a circle, you have to first understand that you can create a sector of a circle by drawing in this triangle. If I join point A to O and point B to O, do you see how I made triangle AOB? Well, now this whole region here that's bounded by these radii and that arc is a sector. So if I find the area of the sector and I remove this area of the triangle, then I will have the area of the segment as a result. So that's how you need to find the area of a segment. Find the area of the sector and subtract the area of the triangle. So question 7 in your notes, and by the way, in your notes, you might want to kind of shade it. It's not shown very well shaded here, but this is what we're calling the segment of the circle. So on number 7, it says to add a triangle so that the segment and the triangle form a sector. So you're going to join, just like I did in my picture, A to O and B to O. So we found this triangle here that we're going to find the area of the sector and subtract away that area of the triangle. So we're going to do that in example 8, and I'll just warn you that there's many steps to this process, but none of them are particularly difficult. Okay, so question 8, you'll see, has 4 different parts. We're going to go through all of these parts in order to find the area of the segment. We're going to round our final answer to the nearest tenth. So you're not going to round any of your answers until you get to the very end of the process. Now, on your notes, you do need to add a little part here. It says draw the perpendicular from the center of the circle to, and then it doesn't say what to draw it to. So right here in your notes, if you'll put segment AB, that will help a lot. Okay, so we're going to draw the perpendicular from the center of the circle to segment AB. All right, so I'm going to do this on the notes, and I think maybe that might be a little bit easier to follow along with instead of the notebook. But I'll do this in the next video.